Hello everyone. In this particular session, I'm going to show how to generate graphs in EpiData Analysis. Um, in addition to showing some of the options in graphs, I also want you to appreciate the process I'll take you through of using the menu as the first step and learning how the code is written in the background. Okay, so let's start. So let's begin with the menu based option. So graph here, and there are several options starting from scatter plot, line diagram, histogram, bar chart, box plot, dot plot. You can read all about these in the help file to understand more about when to use what. Scatter plot in brief is used when you have two continuous variables. Okay, and histogram is for a continuous variable when you want to give a frequency distribution. Line diagram is to show trends. Bar and the pie charts are for categorical data. Box plot, dot plot, these are all for continuous variables. Each one gives a different one. Let's look at quickly some of the options. First, let me read the data set. Okay, so now I've read the data set. Let me also open my program file. Okay, so the program file is also open. Let me begin with the, let's say, scatter plot. Scatter plot. So let's try and look for two continuous variables. We have one weight at diagnosis, and then one more we have weight at the end of treatment. These are the two continuous variables. Let's see if there is a correlation between these two. So scatter plot basically helps us to look for correlation. Okay, now there are two options here. One is run, other one is execute. If I press run, this particular dialog box will disappear, and the next time you want to make any adjustments, then you have to start from scratch. But if you press execute, this dialog box will remain active and open. So in case you want to make any adjustments, it is possible. So whenever you are trying out the graph for the first time, keep clicking on execute until you get your graph right. Is that clear? Let me execute. Okay, can you see here? It's a nice scatter plot that you have got. And then, but the title looks a little weird. It's got cut. Maybe we have to change this. Maybe we have to change the title. Let's understand how to do that. Okay, let me cancel this. Let me try and show you another graph, maybe a histogram, and then I told you it's a frequency distribution. I can run a histogram of a age. So you must also note the commands. So the command for scatter plot is scatter, and then you put the x variable and the y variable. Similarly, histogram, the command is histogram and then your variable. Okay, and it is giving you some sizes here. So size x means the size of the x-axis of this box, and size y means size of the y-axis of this particular box. So if you want so that the title is visible here and want the x-axis a little longer than it is currently, you could copy this command, put it here, and then instead of 400 increase it, maybe 600, and then see what happens. So now you see it clearly showing all the title and everything. Is that clear? This is a simple way of doing some manipulation. You began with the menu, look at the codes, and then begin to manipulate. Okay, let me clear the screen. Let's go to another one. Let's say a bar chart. How does a bar chart look? So bar chart is for categorical variables. Let's look at our main outcome variable, outcome 2, and then run it. Great. Now I have how many have a successful outcome and how many have a unsuccessful outcome. Is that clear, everyone? Okay. Now let's look at another example, maybe a box plot. Everyone knows what's a box plot? It's a plot of a continuous variable where you want to show the median and interquartile range. Median and interquartile range. So let's look at this. Let's take age. Let's also take by some variable. Let's say diabetes. Okay, age. I want to look at the median age of those with diabetes, those without diabetes. Now here, let's go through a process. Let me click execute. So already you see now there are two box plots here, and let's look at it carefully. So if you look at this box, and then there is a whisker on either side. The box, the dotted line in the middle indicates median, and the ends of the box, the two lines of the box, they indicate interquartile range. And by default, the whiskers indicate 1.5 times the interquartile range. 1.5 times the interquartile range. If you need anything else, you have to ask for it. Okay. So there are several other options that you could ask. Now before we go there, let me show you some of the other options that is available here. So this is the variables where we have indicated. There's something called graph or axis. Now here I can clearly tell what should be the minimum and maximum for, let's say, y-axis. Now by default it has taken something, but if you want to change that, if you want to begin from 0 and go to 100, we can do that. So let me quickly show you, just for the sake of options. I'm going to say let it go from minimum is 0 and maximum is 100 on the y-axis, and maybe I will say increment of 10. Okay, something like that. So graph size also you can indicate if you want it slightly elongated than currently. So currently size y is 300. If you want it a little more, then make it 400. Okay. Similarly, width, if you want to increase the width, you can do that. Okay, fine. So let's look at some other things, like for example titles. Okay, if you want to give a nice title to this, let's say age distribution of MDR-TB patients by DM status, something like that. You can also give maybe subtitle, Kerala 2009-10 India, something like that. You can also give a footnote, maybe what is DM, we don't know, so let me explain that in the footnote. Diabetes mellitus, something like that. Okay. Similarly, x-axis text, it's fine, diabetes mellitus. Y-axis text, maybe you have to mention age in years. Okay. So like this you can keep giving as many options as you want. Let's execute and see how it looks. Do you see it? Great. So now you have something already here. So let's look at the other option in miscellaneous. Now here you can save the file as you have to give the name, and then you can give in what format do you want to save. Now let's say I'm going to say simply Boxplot as the name, and dot, you can save the file in 3 formats. One format which comes by default is a .png format. The other format is .wmf. It's a Windows metafile format. It is a vector graph format, and I'll show you in a little while how the quality of a vector graph is so different as compared to other graphs like PNG. Okay, so I'm going to save this as a vector graph. Let's execute it. Okay, it says, I think it has got saved. So for that to check, we have to go to our course folder, EpiData course. Let's look at it. So you see there are all these graphs. Every time you click and execute, a new graph is generated. Okay, all of these are accumulating in your course folder. I will later show you how to clean this all up. But the one which we need is here, Boxplot WMF. If you double click on that, it will open and you can have a look at this particular graph. Is this clear, everyone? Let's go back. Okay, let me close this and then now look at the code. Now what is very interesting is whatever you did till now using the menu option, we have got a code. I can select, copy it and paste it directly into my program file. Is this clear, everyone? Because this is very important. So it helps you do whatever you want in the menu, but then you can copy the code and put it in the program file. Because if you don't like, let's say, title and you want to change the title, if you have to do via menu Boxplot, you have to choose all the options once again right from scratch. Is that clear? So menu is not very efficient. Whereas if you had already copied it in your program file, then you have the code. All you need to do is go to the suitable portion. Okay, here it is the title, and if you want to change the title something, you can do it here. It's very easy. You want to change the subtitle, change it here. Footnote, whatever you want, all that you can change it here. Now let's learn, because the program line is so long here, let's learn how to bring it into the field of view. So there is a nice option called backward slash, which means that it tells the computer EpiData that this line, this particular command is still in continuation. It's not yet finished. So you can do as much as you want so that it all looks neat and in the field of view. Do you see this? Yeah. Do you know how to use backward slash now to indicate that this particular command is still continuing? Clear? And then you can learn more options about Boxplot. And I mean, here itself intuitively you can see Boxplot is the command, variable is age, by DM that you know already, size of the y-axis of the box, y minimum 0, y max 100, increment, so you have 10-year intervals here, title, you have given the title, subtitle, footnote, it's all intuitive, and then you can begin to manipulate it here itself. Okay, if you want to learn more about Boxplot, let us say, write Boxplot in the command line and then press F1, and then it will take you right there into the Boxplot in the help file. So now you can see P1090. If you want the length of whiskers at 10th and 90th percentile, you can do that. Option R, length of whiskers are at maximum and minimum. So similarly, option out will show all the outliers outside the end of the whiskers with a circle for each observation. Do you see this? So there are several options. In addition, you can also have several general graph options. These are common graph options for many all graphs. Okay, so here you can look at changing color, font size, whatever you want. Is that clear? Okay, so let's go back and look at our Boxplot. Okay, and maybe I want option P1090. Okay, so let me run this. So select this and F8. Okay, there is an error message. Why? This particular file already exists. So you have to put a option replace. Great. So now let's do this. Let's run it. Great. So I'm going to go here and open this. Okay, fine. I've got my Windows meta file. Let's go back. Let's say I want to show outliers out, and let's say I want a black and white graph. Option BW. So you could add as much as you want, and now you can try. Okay, it's done. Let's open this. Okay, now I've got a black and white graph with outliers. Okay, so in this way, you can keep doing. And let me just show you the resolution of a Windows meta file. I will copy this. Let me open a PowerPoint presentation. And copy properly again. Copy. Paste. And then here I can make it big. You can make it as big as you want, but the resolution will remain intact. This is one of the common problems. When you make a graph and submit to a journal, and then they will come back to you that this is not in, the resolution is very low, and when they drag it, it becomes blurred. The advantage with the Windows meta file is that does not happen. Doesn't matter how much because it's a vector graph. Is that okay, everyone? So do you appreciate how easy it is to begin with the menu option and then get the code so that you have it all written? So tomorrow if somebody says no, I don't want this title, then you can just change the title here and you will have the new graph in no time. Okay, everyone? Just one last option that I want to show you. And that is, so for example, Boxplot age. Let's say this is what you get. There is an option called option edit. When you do this and say, the whole graph opens in a whole new window, and here you can have several options, several options. And in addition, you also have an option called edit all. And if you click on edit all, it leads to several manual options that are available. You want to change color, axis, titles, legend, and in each, and if you go to titles, again the style, position, format, text, there are so many options that are available for detailed formatting. Is this okay, everyone? So let me close this. I wanted to show you something very special, which is called a CI plot, confidence interval plot. This is a plot of confidence intervals. Let's click there. I want to, let's say I want outcome 2, that's my outcome, and let's say by, let's look at our key association that we saw, which is alcohol. Okay, so I can put alcohol outcome 2 and then say execute. Let's see what comes. Very nicely, I have now got consumption of alcohol. So this is outcome is unsuccessful outcome. Totally 37% had an unsuccessful outcome. Among those who consumed alcohol, it was 87%. Who didn't consume, it was 30%. And I've got the 95% confidence interval around each of these proportions. I've also got a not recorded, which we can always exclude. So let's quickly close this and let's say if alcohol not equal to 9, so that I get only yes and no. Is that clear, everyone? So now you can very nicely see confidence interval plots. Okay, and there are several options by which you can make your graph beautiful, change your title, do whatever, remove some of these lines, etc. But it clearly tells you that the confidence intervals do not overlap, and so the unsuccessful outcome among those who consume alcohol is clearly much greater as compared to those who don't consume alcohol. And this is surely statistically significant because the confidence intervals are not overlapping. Is that clear? So this provides a great option to plot the confidence intervals. Okay. So similarly, you have several other options, and I will leave it for you to explore further. And one of the special things about EpiData analysis is the statistical process control charts, and this is one of the advanced options that is available in EpiData analysis. You can read all about this in the help file and learn how to make use of it. Okay, so to summarize, we have learned how to use the graph options which are available in EpiData. Particularly, I want you to appreciate the process that even if you don't know much about how to create graphs, you could begin with the menu, click around, and then the background program line, you can copy that into your program file and then use it for further manipulation. Okay, thank you very much.